This is a production of Cornell University.
Welcome everybody to the show. No slides today because we've got our expert meteorologist and climatologist and environmental physicist and everything else we can laud my colleague Art DeGaetano with. Art, I'm not going to waste any time. When we wrapped up at the end of the year last year, you were pretty positive on the La Nina effect that was going to, bring that snow through the Ohio River Valley, likely up towards us. They were going to get their share, cold, snowy. I also read a little bit that maybe it turned out to be a weak La Nina thing. Let's start there, looking back.
Yeah.
How did the La Nina play out? And then we'll get into the whys and wherefores with how the winter's been.
Yeah. Also, I don't know if I can, but I did bring up a couple of websites, so they're not slides, but maybe that might be a useful way of sharing. So if you could turn on the sharing, Carl.
Carl, you got him? Beautiful.
All right, you should be good to go there, Art, and then we can walk us through some of the great maps. Sure, he's going to be on the forecast website or the NRCC website, right, Art?
Actually not. So,
Okay.
Can you all see that?
Yeah.
So Frank, I think the best way I could characterize it is I think there were at least two or maybe three ingredients that came into play. And I think what that really did was took the La Nina pattern that we had and sort of put it on steroids, basically. So, here's the weather map for a La Nina, and I've taught you well over the years. Basically, what you typically see, if you think of this purple line as being the jet stream, it bulges up a big old ridge in the west. So you might, if you follow the weather across the country, up until now, Colorado's had no snow, so all the skiers have flocked east. And then if you look in the east, that jet stream kind of dips down, and really the colder air, if you kind of look at New York, we're kind of on the area where it's starting to go up again. So, the coldest air typically lies to our north and west during a La Nina year. It is usually a wetter pattern for the Ohio Valley and drier for us. And actually, when we talk about it, I think we have had a drier winter than normal. So it's really the cold that has been in place. What I don't have a map for is there's another oscillation. In this La Nina thing, it gets its origin way out in the Pacific Ocean. The ocean's either very warm or very cold compared to normal, cold being La Nina, warm being El Nino. And that's why the jet stream kind of sets up this pattern. There's a lot of ocean up there. It affects the atmosphere. It affects where the ridges and troughs kind of set up. There's another oscillation out in the Atlantic. It's called the NAO. It's not as predictable as La Nina or El Nino, okay? And basically what we've seen this winter is called a negative NAO. And really the thing that a negative NAO does is exaggerates this trough over the Northeast, okay? So basically, La Nina kind of keeps us cool. That negative NAO keeps us cold. So that's the second ingredient.
Okay. So is there more ingredients, or is that the
yeah, you might laugh at me, but the second ingredient is climate change.
Yeah.
And it's the fact that the Arctic warms a lot faster than the lower latitudes. And what that does is when there's a big temperature contrast between the Arctic and the mid latitudes, the jet stream is really strong. And when the jet stream is really strong, it's like taut. It doesn't have a lot of waves in it. When you relax that temperature gradient, it gets very wavy. So it's wavy due to La Nina. It's wavier due to this positive NAO. And it's even wavier beyond that due to the climate change.
All right, this is great.
What climate change does is persistence. It keeps that pattern persistent. So,
So what I heard is that we had a La Nina on steroids, and climate change amplifies a lot of these things. As you've taught me over the years. How did it play out in anomalies? We were dry, but it just seemed like the snow came, Art, like in November, and it really stayed because of the persistent cold. Have we been colder than you would have expected?
So that's a map of rankings in terms of coldest across the
Ah,
Northeast. It's for the last kind of the past month, the past 4 weeks. And I mean, that's
mhm,
been kind of the heart of it. If you kind of can think back, we were pretty warm right after Christmas, right into the new year. We had a warm
mhm,
period, and then the bottom fell out. And we've
mhm,
been cold pretty much up and through this week. So basically, those numbers are the ranking, with one being the coldest on record,
mhm.
and three being the third coldest and things like that. So I
So
don't
it looks
know,
like a lot of single digits, Art.
a lot of
So
single digits.
a
So I
lot of
think,
single digits.
yeah. So the last 30 days have definitely been, I'll say, you can look there, definitely top 10 across the region as a whole. Um, One of the things that I pick out on kind of maybe the difference in this, and again, you can play, it's like sports, you can find all kinds of statistics
Oh,
and
gotcha.
say,
Stats in stats.
coldest,
Stats in
highest.
stats.
Yeah. No, I don't think it was particularly cold from like an extremes perspective. I don't think here in Ithaca it dropped below -10 ever or something like that. Yeah, there were a couple of really cold days where the maxes didn't get above the single digits. But I think really what contributed to this map and this ranking is just the persistence of things. We got locked into this cold pattern, and day after day. Longest, again, where I can say sports statistics, we can look at many stations and say, yeah, the longest stretch of consecutive days that didn't get above 25, if we're kind of maybe down in the city. So that was the thing that was really key here. And then also a lot of places, there wasn't a lot of snow. There was that one big storm that kind of was ice, and it kind of was a fizzle for us, even though they closed the university and things like that. We got snow, but not record-breaking snow by any chance.
Mhm.
Um, that snow stuck around. So if you were in a place like New York City or Philly or something like that, that was another kind of very unusual thing over the last month, that you had such a snowpack persist. And actually, the more unusual thing is it persisted without really being recharged. It fell that one time, and there were, yeah, maybe a little piddly
Right.
events there, but just because it was
Yeah.
so damn cold that it stuck
Yeah.
around.
And this particular persistence, Art, um, plunged all the way down to the Carolinas. I
Yeah.
was talking to people down there. They had snow for weeks.
Yep.
You know from being down there, they get a snowstorm, it's gone the next day, 2 days
Yes.
later. But
Yep.
even with a couple of days in the 60s and 70s down there, they've still got snow on the
Yep.
ground. So that unusual that it plunged that deep? Is that the elasticity of the jet stream that brought it down that far?
Yeah, I mean, yep, that's everything on steroids, right? So it's not only, yeah, it's how deeply that cold air plunges, and that's exactly what happened.
Now, one of the benefits that we've had from a growing grass perspective, I'd like to believe, is that, and I don't know how much you're monitoring the temperature under the snow, but certainly the snow, if you got a lot of snow, that had to be good relative to all the cold weather because that provides insulation. As you get down to the city and a little bit north, and certainly into Kentucky, Tennessee, and those areas, they got tons of ice, and ice not such a good insulator. And so I'm wondering, have is there soil temperatures that tell us how deeply the cold penetrator, how deep the frost has been this winter, and was that buffered at all with the snow cover that or ice that we had?
Yeah, you're catching me off guard. I really haven't looked at that data for soil temperatures. I would say the data that are out there are few and far between.
Mm-hmm.
But some work we've done in the past, actually for the construction industry, for like how deep you have to bury foundations and footings and things like
Mm-hmm.
that.
Mm-hmm.
This is the classic winter where you would not get much frost penetration into the soil. So I would say, up here in Ithaca, any place where we've had, a foot of snow on the ground or even 6 inches of snow on the ground for a period of time,
Mm-hmm.
I don't think the soil ever froze this winter, basically. I think the soil remained pretty darn close to freezing any place kind of north of the city and things like that. You're
Okay.
absolutely right. The ice is a much worse insulator than the fluffy snow is.
Yeah.
So, again, even in a place like Kentucky or something like that, I don't think they saw the persistence in the below freezing temperatures that there was significant soil freezing there.
Okay. I want to shift a little bit before we get into prognosticating and talking about springs and false springs and what that's been like over the last decade or so. I want to talk a little bit about light levels. I get to travel to other parts of the country, Art, and particularly in the desert Southwest where, it's warmer, and they grow cool season grasses through the winter out there. But underneath that are warm season grasses that are trying to rejuvenate themselves to get going again. The cool season grass dies out when the heat comes, and then the warm season grass comes on, and then they go through the whole process again. One of the things I hear from these guys is right around February 15th, in their mind anyway, light levels really change. Is there, and we also hear the same thing about August 15th from the turf managers up north. Oh, once I get to August 15th, the sunlight is blah, blah, blah. And listen, we know that's driving ET, especially a significant fact in August. Is there something about our orbital position in either February or August that actually adds substantive light levels that could lead to warming or productivity should temperatures be adequate for
Yeah,
such?
again, you caught me off guard with that question when you sent me the couple of bullets. But
Yeah.
actually, thinking about it a little bit, yeah, I could see if you think of how seasonal light levels kind of progress through the year. And yeah, I'm going to get a little bit mathy, but
Let's go. Let's go.
basically it follows a sine curve. So
Mhm.
if you kind of think of it as
Mhm.
this, and really in those periods of time that you talk about, kind of this time of February, I would have guessed a little bit later than August 15th. You're not on the top of that sine curve or the bottom, but you're on that part where the slope is very, very quick. So you're
Mhm.
seeing that quick change in this case, the angle of the sun. So that means how directly the sunlight is interacting with the turf and things like that. And also the length of day. So it's not only how direct the sun's rays are, which makes a big difference, but also just what your length of photo period is, your day and night type of thing.
Yeah,
So
and the reason I bring that up is as we make this transition again, growing grass here in the Northeast, a lot of guys use pigments or darkening agents to try to draw some heat to their surfaces. Can you talk a little bit about the sort of physics of, why something dark works like that? And does what you just described in that slope really potentially add the possibility of heating these systems in a way that will be maybe cumulative, right? The sun's getting in the right position. I'm trying to darken my surface. There's a lot of question whether that's a good idea to get things going because if we get a cold snap again, it could create problems. I'm wondering about the physics of warming systems with darkening agents, trying to capitalize on any increasing in light, not necessarily length of day, but in
yeah.
intensity of light.
Yeah. So, boy, I'm going to have you come and teach my environmental physics class next week because that's exactly what we're covering. So
Oh,
that would be
excellent.
perfect. So, yeah, I can again. I can't talk about the effect on the grass and the turf and things like that. But clearly, the darkening agents, particularly at this time of year, yeah, that's. I mean, you're spot on, right? So you think of the sun coming in. We talked about the directness, and once that sun kind of interacts with the Earth's surface, pretty much two things can happen. It can be absorbed or it can reflect.
Okay.
Okay. And as you make the surface darker and darker and darker, you absorb a greater proportion of that incoming radiation. The last couple of weeks have been great. If anybody's, I know it hasn't been sunny up here all that often, but on one of those really bright blue sunshiny days, it was so glary walking across campus because of all the snowpack. So there
Right.
you've made the surface white, and white is a good reflector. So that's kind of the opposite of what you're talking about. That probably contributed to a lot of our cold as well. We had a good snowpack, so that kept things a lot colder.
Very
Um,
interesting.
you see the same thing. Some of the other work we do is with actually road freezing. So
Mhm.
like in the north in Maine, they when the roads freeze, they let the trucks carry heavier loads. And there in our equations, it's basically degree day based, just like things in turf, but we
Mhm.
have to take into account solar radiation. So that kind of like you say, that time of the year, you get more bang for your buck on a warm day now than you might have in the middle of winter because of exactly what you're saying.
Okay, so then the next thing follows that we live in the cloudiest place in the whole damn world. How much do the clouds impact that solar radiation when I'm trying to warm it up? Do I get that? I just have never felt like I get the same warming of these dark surfaces when it's a cloudy day. Do I? No? Yes?
The
What?
clouds negate everything.
They
They're,
negate everything.
pretty much.
Okay.
You're just reducing the amount of solar radiation that's coming in so much on a cloudy day that you could argue maybe it has a minimal effect, but you don't have that strong effect. So
Okay, so I would be remiss if I didn't bring up your expertise as a NCAA soccer ref. And I know that one of your favorite surfaces to run around on is the black synthetic turf at Morrisville. Can we expect those synthetic surfaces that are darker like that to be less likely to stay frozen? Will they absorb that heat just like we're talking about everything else and be really beneficial at this time of year in maybe providing even better than a green surface or
I,
God forbid a blue or red? I mean, who the hell
huh,
knows what they're making these things colors out
yeah,
of?
right.
I
Because
would have never thought they'd make it out of black, but they
yeah,
did.
well, I think
Thoughts
if you're
on
out in
dark synthetic turf?
yeah, I think if you're out in Iowa, or Idaho, it's blue, right? Is that
You're right.
where the
That's
blue?
right. At Boise
Um,
State. Right.
yeah. Boy, yeah, I think so, Frank. I think actually these synthetic turfs, even when they're the typical green, I think they're dark enough that you're getting a significant amount of absorption of solar radiation, right? The black infill and the dark. I mean, I think they're right. Those synthetic turfs are warmer on a bright sunny day, and I would think at this time of the year as well. You have that same effect. You probably get a little bit of benefit from the black compared to the green and things like that.
But not much.
Yeah, not much. I think also the issue might also be just the amount of drainage and things like that. When you have the natural surface and you have the moisture there, right? When that radiation is coming in, when that energy is coming in, it's basically got two things to do. It can evaporate water and it can heat up the surface. So
Mm.
with a well-drained synthetic field, you're taking away that other thing that the energy has to do in that case.
Mm.
So what's left
Mm.
is for it to
And,
warm
and
up.
and at the same time, one would think the black surface would be significantly warmer in July and August than a green surface, would it,
Uh,
or not so?
Ex yes, exactly. For kind of the same reasons.
Yeah.
It's absorbing that radiation and it's not evaporating any water.
Mm.
So, it's not you're losing that other thing
Yeah.
that the
Okay. All right. So let's pivot to the spring now, right? And I guess I want to start out with the people who don't always listen to us talking about this. There's a couple of signals or trademarks that I would say the springs have had, at least in the last 5 to 7 years, where certainly we get a warm up and then it sits there for a little bit. And then it's not uncommon to get that, deep cold again. I mean, listen, we accept on this program that climate change is a fact. We're not going to debate. We're not going to go Herb Stevens on us trying to make up some mumbo jumbo about whether climate change and it's all some kind of government conspiracy. We're not going there. We're going to accept that the climate's changing because I'm with an environmental physicist who looks at numbers and studies the climate. And with that as a background, Art, how in your mind over the years we've been doing this, did I sort of touch on what the trademarks of a spring is now in a climate transition world where we get that warmth, it sits there, some deep cold, and then boom, it seems right into summer we go
Yeah.
without any meaningful transition.
That is definitely something we've been seeing lately. It's hard to go back to the numbers and crunch them and say, boy, there's definitely a trend here. But I think we can almost come full circle where, as I mentioned, under climate change, the jet stream tends to be wavier. Okay. So if you think about that, as you come into the transition period and the jet stream is wavier, when the ridge is sitting over you, right? When it's humped up over you, and it's late February, it's early March, it gets warm. I mean, and the grass, the everything starts to respond to that, right? I think at that time of year they're very thermal sensitive. So the buds in the apple trees start to develop and whatever. But having said that, there's still a lot of time for it to get cold. So when that pattern shifts, you have this advancement of the vegetation, and then they get zapped by those colder than normal temperatures.
It is when you keep talking about waviness and we keep talking about shifting. I guess over the years, I've thought about, we get in a pattern and we tend to stay locked in it. Is that also a signal? Do we get stuck in these patterns more or do they change less? Tell me about how much things change once we get locked into a jet stream pattern.
Typically, when you get wavy, you tend to, it's called, usually it's a blocking pattern. So you can make your analogy there, Frank. But so they tend to be more persistent. So you have seen there is some evidence to say, weather systems have become more persistent. Once you get stuck in a pattern, you're locked in that pattern. That's not to say it stays there forever. So again, that goes back to these false springs, as you say. It's going to warm up. It's warming up now. I don't see a big change back to the deep freeze. Up here we'll see probably a few borderline snow events, but we're going to be, warm. We're going to see highs in the 40s or something, maybe, in the next few weeks and staying there. But then it's going to be that one event that comes through in April where it gets really cold at night. We're under a nice high pressure system and the earth is radiating, and you end up getting that killing frost.
All right, I'll wrap up some of my questions with your comment about how dry it's been. And I'll go back to the last couple of falls. I know 2 falls ago it was so dry, mowers were catching on fire, sparking near dry leaves. Maybe it was last summer, the dean's house almost burned down because of a fire that started along the road. Are you worried about streams and rivers and groundwater, or did we get enough over the last couple of falls? Because, certainly going into the season, a lot of states that rely on groundwater for irrigating things, golf courses or otherwise, might get some restrictions if groundwater's not fully recharged. Can you talk a little bit of, certainly it feels like there's been a cumulative drying that's occurred the last couple of years. Can you speak a little bit about moisture in the system these days?
Yeah, I mean, particularly in New York and New England, the moisture in the entire system, I think, is lacking. You see it, in a lot of the longer term groundwater wells and things like that. We've been dry. It was dry in the fall. Actually record breaking dry in like places like Maine and Vermont and actually into, eastern New York, kind of, just south of Lake Champlain. And I really don't see that we've gotten enough rain or snow actually over the winter to kind of overcome that. What we see in groundwater in the Northeast is the big thing that really factors into the groundwater being recharged in the spring is how much snowpack you have in the surface. So I mean, if you're listening from the Tug Hill Plateau or, maybe even like Rochester or something like that, where you've got hammered with lake effect, which again is a classic sign of a La Nina winter, maybe you're doing okay. But in other places, even the foot of snow we've had here in Ithaca probably was no more than 2 inches of water in it. So,
when you start talking about Maine and Vermont and places like that, where, 12 people live total. They're all relying on groundwater, right? And so when they don't get that snowpack and you're out in the countryside and your well goes dry, you got to call Wally
Yep.
to show up with the well water to fill up your thing. So, I mean, that can be really concerning. Are we at that point where people might be in trouble for the season?
I think it's going to really depend on how the next month or two shakes out in terms of
Wow.
rainfall and things like that. I mean, again, if we do have a wet spring, again, I don't see any real signs of that shaping up. But that would be the thing there. I think the next
Well,
couple
I
of
got to
months
tell
are
you,
really going to
I'll
tell.
shut up after this, but boy, I love the La Nina. I went to Southern California, and that was a sweet spot for La Nina. It was warm and dry and sunny, and they normally get a lot of clouds
Yeah.
at that time of year. And La Nina definitely seemed to clear it out the way it was bringing the warm air in and the clear skies. All right, Carl, comments, questions for our expert here?
Yeah, I think, and maybe on the La Nina El Nino front. So Art, a lot of those two systems are driven. You mentioned it by the ocean temperatures, and there's sort of this wave of warm water that goes back and forth, and that sort of drives those things. And when I look back at some of the irrigation work Frank and I have been doing, you see sort of this pattern of, like dry year, wet year, dry year, wet year. And then even within the seasons, is there a, two dry falls recently? Is there a rubber band effect? And would there be any sort of larger macro patterns in the jet stream or some otherwise that would have this rubber band effect of dry and then wet, then dry? Is there anything in that, or am I reading too much into a
I mean,
10-year period?
I think in some parts of the country, yes. I mean, you can think of the El Nino La Nina is kind of like a rubber band. I mean, you can think about it as Frank doing a cannonball in the Eastern Pacific, and the water sloshes to the west, and it hits the western continents and then sloshes back. So there is that kind of periodicity to things. And so you would see that more in parts of the country, parts of the world that have a very strong El Nino precipitation signal. Southern California, Florida, even. Up here, there's other, we're kind of far away and there's other things that come on. So you might see that a little bit, but not as strongly. So I mean, kind of if you were betting and you could bet over, a bunch of years, yeah, I might bet on that rubber band effect, but you're going to lose in a bunch of years too.
Okay, speaking on betting, now that we can bet on anything like the end of the world and every other thing that apparently you can bet on, you want to give a general, I mean, looking out at what you're looking at, you certainly get to see more data than we do. And it's not, I'm not looking for a fine prediction, but certainly a lot of folks in our industry are wondering, when is the snow going to go away? When is the cold going to come out of the ground? When am I likely to get back onto that soil? Certainly in the golf world, the sports and school world, they want to get out and play on some of these natural grass surfaces. Lawn people, they are in a hustle always to try to get out there and start cleaning. Thoughts on what we could put money down on for when the snow's gone and I can get to work on the ground? Am I a month out? You think I'm a few weeks out? What does it look like, Art?
Well, first, if you make any money, Frank, I get a cut.
All right, we're going to have lobsters together.
All
You and
right.
me will have some
Sounds
lobsters.
good. So I see, kind of looking at in my crystal ball and the longer range stuff, I think we've kind of turned the corner. Right? We've had a couple of upper 40-degree day here, a couple of 50 days, downstate. I'm not going to say that that's going to persist, but basically, I don't think we're going to see any of these, days that it doesn't get above 10 or 20. The pattern kind of has flattened out and things like that. There are a few storms that are on the horizon. This one over the weekend, the models were all over the place. It looks like that one's going to go out to sea, so I don't see a substantial threat for snow from that
very
one.
good. Excellent.
Couple of more in the next 2-week period, maybe some snow up here, but mainly rain events to our south. So I really see that change kind of coming basically in
And
terms of getting out of
temperature-wise, we're warming up enough where that frost is coming out of the ground and at least that water will start to move through other than sheet off.
Yep, no, definitely. Again, upstate, still highs in the 30s types of things for the next couple of weeks. cool down the beginning of next week. So even downstate into Philly, into Washington, probably a couple of days in the 30s, but that's going to be short-lived. And, I think we're around the corner. There's going to be a couple of last gasps, but I think we've turned the corner.
You heard it here. Place your bets. What's that website you can bet everything on? What is that thing called, Carl?
There's several, I think.
Okay, that you can bet on anything, like what the market's going to do, or whether we're going to get a fart out of the Congress or something. It's unbelievable. Art, always lovely to see you, brother. We'll start the call up in another month or so, and then we'll check back to see how well this prognostication for everything went. Really appreciate you taking the time and getting us some fact-based information about the way the weather is. It's certainly been on everybody's mind. I think this is the longest period of time a lot of guys have not been able to get out on their properties, cut trees, do drainage because of the persistence of the snow. And now the transition makes it muddy and wet. And so, you're doing more harm than good many times trying to get out there. Appreciate you taking the time, Art. See you, Carl.
This has been a production of Cornell University, on the web at cornell.edu.